Thank you, thank you. Please grab a seat. We're going to start in about 30 seconds. Thank you, thank you, thank you. All right. Thank you all for sitting down. Thank you all for grabbing a chair. Cool. Okay, I guess we can start. Thank you all so much for coming today. My name is Tom Nakata. I'm one of the co-hosts today. And just to quickly introduce myself and the event before we jump into the actual content of today, presented by Qdrant and SambaNova. I just wanted to quickly introduce what we do as a company at Qlay. We are the co-host of the company, and a little bit about myself. I'm the co-founder and CEO of Qlay. The co-founder and CEO of Qlay is operating the cameras today. Previously, I was at McKinsey. I was doing a lot of organizational strategy things, but now I founded this company, Qlay. And what we do actually is to help other startups build their organization, namely their technical engineering teams. So that's why we're helping other startups hire or find, hire, and pay vetted global engineers. And the reason why we're doing this is because we used to hire a lot of engineers off of Upwork, but this we found tough because we still had to do a lot of vetting processes on our end, and we had to interview all these people. So that's why we built an AI model that would do this for us. So we essentially built an AI recruiter that would source and then interview them and find the best one for your position. So what happens is we essentially build this system so that you can accelerate your hiring processes. It used to take around 2 months to hire one person for this one position. Now we are able to finish this in 1 hour, essentially the final interview only. And we're also able to cut costs for you as well. Because if you were to hire a senior full stack developer in California, it would be hundreds and thousands of dollars. We're saying, okay, why don't you hire someone abroad for a more sustainable cost structure for your startup? Right now we're doing around 450,000 in ARR. We did our beta launch last July. We've been growing at around 70% month over month, mostly with customer referrals. We just signed on our first public company last week, so we're able to grow ourselves from there. This is the last page before we jump into the content. Right now we're doing a campaign. It's that if you book a demo call with us for your hiring purposes, we're able to offer you a discount of 400 engineering hours for free. We think this is a really good deal, but we're essentially trying to lower the hurdle of hiring and trying out working with other engineers as much as possible. I'll be around today during the networking event, so we'd love to chat with you all later. Without further ado, we'd love to jump into the first session, and that's Thierry. Okay, sounds good. So today we have Thierry from Qdrant here today. Thierry, do you want to come back?
Yes.
Come up and connect your... All right. Everyone please give a round of applause to Thierry.
Testing. All right, how's everybody doing tonight? Woo-hoo! Thank you so much, Tom, for having me. Thank you, Qlay, for having me. Excited to be here tonight. Let me make sure that everything is working. Okay, awesome. Thank you very much. So I always like to start off all of my presentations, or talks I should say, with a selfie. So that's the first thing we're going to do. If you're in the back there and you can just make a silly face, I would appreciate that. On 3, 1, 2, 3, wow! Okay. And I also have this Qdrant mug here, which I will be giving out to one of the lucky people in the crowd. So if you want a mug, come up and talk to me. Tell me how you're using Qdrant or how you're using vector databases, and you could win this mug. So what I want to talk to you all today about is something called MiniCoil. And MiniCoil is actually kind of, I was thinking about how we have this dragon on the ceiling here, and it kind of reminds me of trying to tame chaos. And in many ways, MiniCoil is Qdrant's attempt to tame chaos. Because in search, if you're not too familiar, we've always been looking for this kind of golden place, right? A lot of people think of the Roman Empire as this golden place. One of my colleagues was telling me that apparently there's a meme going around about how everyone's always thinking about the Roman Empire. And in search, our Roman Empire is a search system that can find keywords, and it can also find the meaning of words. So currently, we basically have two different search systems. We've got Sparse and we've got Dense. One of them is really good at finding out how many times Hermione is mentioned in Harry Potter. The other one is a lot better at figuring out how many times Hermione was upset in Harry Potter, right? Now, the challenge that everyone's looking for, the golden goose, the ambrosia, if you will, is how can we combine these two things so that I can not only find with accuracy, speed, and precision the times that Hermione was mentioned, but also find the times that Hermione was upset, right? Because currently, the systems to do both of those things don't work too well together. So we came up with MiniCoil, and that's our way of basically creating a system where you can not only do exact keyword matching, but also get a little context from your word. But before I tell you about how MiniCoil works, I just want to give you kind of a rundown of Qdrant in general. So if you're not familiar with vector databases, Qdrant is an open source vector database. What is a vector database? Well, a vector database is going to allow you to take it's going to allow you to take words, images, different kind of data, and basically turn it into numbers. And once you've turned it into numbers, you can then do those classic machine learning techniques such as clustering, anomaly detection, Q&A, recommendations, and all of that good stuff, right? So if you think about Qdrant, some of the industries that we work in, we've got HR tech, law tech, entertainment, anti-fraud. Some of our clients include companies like Perplexity, Johnson & Johnson, Bosch, Disney. So it's these companies with a bunch of data that need to be able to get insights from their data very quickly, accurately, and reliably. So going back to kind of this idea I explained to you, there's two search forms. We've got dense and we've got sparse, and one of them is better at finding the exact keywords, whereas one of them is better at finding the meaning. So what we're trying to do is basically come up with a system where we can find not only the meaning of the word, which is that neural retriever, but we can also find the exact words. And the issue that we currently have is that the neural, aka finding the context or the concept of the word, tends to take up more energy, a little slower, just generally a more laborious process. So we decided, what if instead of having all of those dimensions for the context of the word, we're just going to have 4 dimensions for the context of the word, and we're just going to compare that word to the company it keeps, right? So, for example, if I say, I'm going to go down to the riverbank for a party, or I say, I'm going to go to the bank to make a deposit, I should be able to tell what kind of bank I'm talking about based on the words kind of around it, right? And that's the concept here with this MiniCoil. So I'm going to kind of zoom through some of these technical slides here in the interest of time. But what you want to take away from here is that obviously we've been building search models for a long time. But every time that we've made an improvement in our search models, it's come with a trade-off. Whether that means the models don't generalize well, it means the models are too large, they can't run fast. Keep in mind, Qdrant is all about speed, right? We want to be able to serve those billions of vectors for you quickly. So this is our good old friend BM25. Don't worry, we're not going to do a math class, but I did want to just show you the formula. This is what your typical search is based on. This is going to be that keyword-based search where we're going to look at the term frequency and the inverse document frequency. The problem with BM25 is if I were to ask you, close your eyes, think of a bat. BM25 cannot differentiate between the bat on the left and the bat on the right. It just knows that your text has a bat. So obviously when you're doing a search and you're doing something like cave bat or fruit bat or baseball bat, that's a different kind of bat that you want to pull out, right? So here we have the classic hybrid search formula where we're going to combine BM25 with that neural retriever so that we can get not only the exact word match, but also the meaning of the word, right? The problem with this is it's not the fastest, right? Because we have to do both the sparse and the dense, and as I mentioned, usually those neural retrievers are a little more laborious. So the solution that we came up with was this idea of MiniCoil. And MiniCoil is the BM25 formula that we all know and love. That's basically what made your favorite search engine your favorite search engine. But then we're combining it with these 4D context vectors that are going to give us the ability to find meaning in the word. So now all of a sudden, we know that there's a difference between fruit bat and baseball bat, or there's a difference between calculator and calculating. Whereas when we just use BM25, these two phrases are going to appear exactly the same. And if you're wondering, well, why 4? Well, we chose 4 because we found that that was enough dimensions to give you some information on the word, but it was also small enough so that the search wouldn't get dragged down in terms of speed. Once again, we're very focused on speed at Qdrant. And what we came up with was this MiniCoil architecture, right? And the cool thing about MiniCoil is basically we're just going to be using the 4 vectors as opposed to multiple vectors. And if we don't have any context for the word, we can always just fall back to the BM25 score of the word. So if you don't have a model trained via MiniCoil, you're all good to go. We're just going to fall back to BM25, where you won't get that context, but you weren't getting that context anyways. So the way that we actually trained this model was pretty cool. We used something called triplet loss. And if you look here, you can basically see we've got a fruit bat, we've got a bat that slept in a cave, and we've got a baseball bat. And the idea is these are different kind of bats, but we probably want that bat that slept in a cave and the fruit bat to be closer to each other in latent space, right? The context might be different, but we definitely want to separate baseball bat from fruit bat, cave bat, any kind of other bat, as opposed to a baseball bat. I'll answer questions at the end. Thank you. So here we have the actual projection of what it looks like. And what you can see there is on the right, you have that one clear cluster, which is going to be the bats, like baseball bats. And then on the left, you're going to see a few different clusters popping up because that's the different kind of bats we have. So that might be fruit bat, cave bat, winter bat. I don't know what kind of bats we have, but obviously those should be grouped together closer together. And then I'm going to kind of zoom through the architecture, but I will focus on this here, where typically with Retrieval, we're looking at these tokens. MiniCoil just looks at the words. So going back to this slide here, we can actually tell the difference between calculator and calculating. And as you can imagine, one of them is literally a thing, the other is an action. So being able to tell the difference between those two helps your search be more accurate. So then finally, you can look at an example here where we have fruit bat. We're going to look at the contextualized embedding of bat, contextualized embedding of fruit, put them both through MiniCoil. We'll get the score. We'll multiply that score by the BM25 score. And then we have the dense embedding of the fruit bat as well. Put them together. We've got hybrid search. And these are some benchmarks. So MS Marco is a very popular benchmark data set in information retrieval. And you can see here that we actually did better than MS Marco than BM25 by about 0.07. And that might seem like a small improvement, but given the fact that we didn't train MiniCoil on this data. It's actually pretty huge. But we also want to emphasize that MiniCoil is not about benchmarks. I know I just showed you some because people like benchmarks, but the entire idea with this is we want to build something that's actually practical and useful in prod for real people and real companies that are building search products. We don't want to just build something that kills the benchmarks, but then when you go to actually deploy it, you've got this dependency soup and it's not actually possible. So very quickly here, I want to show you the Qdrant coil demo, and then I will take any question. So I know in the front row you had a question?
Yeah.
Yep.
I like your conceptual idea of vector search.
Okay.
And you said a bat and a bat. A bat is the word and the bat is the...
Yeah. I think she has a mic for you.
Thank you for your presentation.
Yeah.
The vector search for bat
Yeah.
and a bat.
Yeah.
I think to me that's interesting because, this is like the context of how do you ask a question in the AI space.
Yep.
And I think I wanted to ask you a question about the bat itself because that was the question I wanted to ask. And the bat is, if you were to come from the British colonies, the cricket was the bat. Exactly. I don't believe most of the British colonies, like African, Asia, they use a bat.
So that's the cool thing about MiniCoil is it's actually going to depend on the other documents in your text. So if you have a bunch of cricket bats being talked about, then it's going to learn, hey, here's a cricket bat. The documents we fed it had baseball bats and then bats like the animal, so that didn't show up. But if you don't have the word specifically trained, we would just fall back to the BM25 score of the traditional search engine, whatever they consider bat. Yeah. And then just quickly here, I want to show the demo where you can kind of see, I've typed in bat, or let me refresh this so you can see it live. If we look at the bat example, you can see here, we've got these sentences that contain bat, and then the purple ones are going to be the animal. The red ones are going to be an actual baseball bat. So we've categorized here the different kind of bats. So that's MiniCoil. This is Qdrant. You can go to Qdrant.com, sign up for free, no credit card required. And I've got this mug here for anyone who is building anything cool with Qdrant. If anyone has any questions or just wants to talk vector search, Qdrant, information retrieval, BM25, feel free to reach out to me on LinkedIn, X. Hit us up on Discord. But thank you for having me tonight. It was a lot of fun. Thank you to Qlay. Woo!
All right. Awesome. Thank you, Thierry.
Yes, sir. Oh.
Next up, we got Justin Wu from Samba. Wait, doing a. All right, everyone, please give a round of applause to Justin from SambaNova. Thank you.
Thank you.
All right.
Great. Can everyone hear me, by the way? How's the food? Today we got banh mi and vermicelli. Hopefully everyone enjoyed that. Let me just present the slides here. Can everyone see? Sorry, what I want to do? I think I'm mirror. Do a slideshow. I think I want to do is maybe mirror my screen. Just maybe 1 second here to do.
I think it's working. I think you just have to do the slideshow.
Okay.
I think you just have to do the slides.
We'll give it a few seconds. Okay. Let me just. Sorry, guys. Give me 1 second to make sure what I want to do is I just want to mirror my screen. I'm going to go ahead and I just want to mirror the screen actually. If not, that should work. Yeah, no problem. Guys, give us a second here. We're just trying to arrange this. Maybe that works too, yeah. Yeah, I could just move it up there and then...
Yeah, but you want to see your stuff, right?
Yeah, I don't have to see the stuff. I just want to mirror the screen, actually. Yeah, that should work. I think if we... Yeah, just do that there. Then... Yeah, there we go. That's fine, I think. Yeah, we'll do that. Thanks, guys, for bearing with me. I appreciate it. I'm going to have to juggle some of the screens a little bit because I've got some live demos. So today I'm going to talk about vibe coding using open source tools. Who here has vibe coded? Raise your hand. A little bit? Or even you guys have heard of the term vibe coding, right? For sure, right? So I just wanted to talk about me a little bit. I know it's a bit selfish here. I'm a Python developer. I play Qdrant and pickleball. I'm from Singapore, and I have 2 dogs and my wife here. But let's talk about vibe coding. That's why we're here for. You know, I looked up the word vibe. So I only heard about the word vibe this year, and I looked up the word vibe, and supposedly it's, you know, the last one's the most interesting, which is to enjoy, dance, or feel inspired by popular music, which is really interesting when you tie the word vibe and coding to it. But the reason why we're talking about vibe coding is thanks to Andrej Karpathy, who actually tweeted out something in 2023, which he sort of said right now the hottest new programming language is English. And then he followed up with another tweet this year in 2025, and forget the verbal word, the paragraph down here. What he really talked about in that, which is the most important sentence, is he feels it's not really coding. He uses the large language model to code, where he just sees stuff, says stuff, runs stuff, copy and paste stuff, and it mostly works. So for him, that's vibe coding. And that's where we're here today. Another quick etymology lesson about vibe. It's actually short for vibraphone, and it's slang for instinctive feeling. So the reason why I bring this up was, let me try to set the stage and talk about what vibe coding is not. So we all use large language models to help us code. Simon Wilson, a really popular blog, if you're not reading it, I would encourage you to read it. He says not all assisted programming is vibe coding. In particular, using large language models for code responsibly is not vibe coding, but building software with a large language model without reviewing the code it writes is what we consider more or less vibe coding. So if you're just like writing code, and you're not reviewing, you're just hitting enter and go, that's what we think the definition of vibe coding is. So with that, I'm going to talk about like when is it okay to like vibe code or like submit to the vibes. For me, when I'm doing like quick prototypes or like low stake projects, maybe like a hackathon, something I want to build quickly over a weekend. Or maybe when I'm not really considered about security. I think with vibe coding, we have to be careful about secrets, data privacy, like our keys could be exposed, simple things like that. I would also be cautious about being a good network citizen. I think when you're doing vibe coding itself, as you see later on, the network traffic could be really high because you're sending a lot of code through the large language model. The last thing I'll be careful about is you're using vibe coding to access APIs. Be careful about usage, because you know, when you're a developer, when you're accessing those APIs, you normally know what usage you're using. When you're vibe coding, you're submitting to the vibes of the large language model, and you're not necessarily sure what the API usage is there. So the biggest question I have is, like, which model should I use? How about this? Someone shout out a model that you use right now to vibe code. Sonnet. Okay, and actually that's one of the most popular ones. Which version of Sonnet? Yeah, exactly. That's exactly what I guessed. You know, ironically, there's a couple of benchmarks which I'm going to go through. I'm going to talk about 3 different benchmarks. The benchmark that I like to look at is Web Dev Arena. Who here has heard of Web Dev Arena? Okay, some people have sort of used it. So why is this benchmark a little bit special? What it does is, in this benchmark, it's actually curated by real human beings. You type in a prompt, and then it will actually do a blind test and output, like for this case here, the prompt is, build me a clone of Hacker News, and it outputs 2 different versions of Hacker News. And within that version, you actually vote as a human which large language model is better. And this is a chessboard here. So this chessboard here, the prompt used here is make me a game of chess, and you have 2 different. You don't really know which model, it is, and then you as a human will vote for it. And as a result, what comes out is the best model bubbles to the top. So you can see here, like Sonnet 3.7 is second, Gemini 2.5 Pro. This is a snapshot from today, by the way. What's really interesting to me is that the open source models are catching up. Like for example, like DeepSeek is rising to the top. And we're very curious to see how like Llama 4 moves up to the top too. There's another very famous benchmark called Live Code Bench. And this benchmark actually takes code from LeetCode or Codeforces and actually basically does like a LeetCode test or LeetCode test for these large language models. Personally, I am not too keen on this particular benchmark because I don't think anyone who's going to a coding interview, I don't think a LeetCode style test actually, it shows you how good a coder is. And here you got a benchmark of the different models out there too. What's interesting is Qwen, which is an open source model, is bubbling to the top, and then the rest of them are Gemini or GPT. The last benchmark I want to talk about is SweBench. And this one's the most complicated. What it does is it gives a code base and an issue, and the large language model is then tasked with generating a patch that resolves the described problem. And this is a series of like 500 different tests. What's interesting about this particular benchmark is that OpenAI last August came up with SweBench verified. And what they did was they went through, they got a bunch of humans, and then they verified or validated that each particular question can be solved by a human. So to address these issues, they launched a human annotation campaign with a professional software developer to screen each sample. So they came out with SweBench verified. And I think this is the one that most large language models are actually going off. If you look at, and I talked about Claude Sonnet, the one they always highlight that they achieve the best is, so forget the top row, that's reasoning. The second row is agentic coding by SweBench verified. And you see that Claude right now is passing about 70%. But these are bench, you have a question?
Yeah, but these models could be trained on people.
Exactly. And I love that you brought that up. The reason why I talked about these benchmarks is in my particular, I think this is a controversial part, but I just want to repeat what, sorry, what's your name? Kai? Hein talked about, which is a really important point. These models can be trained on these benchmarks to pass. Just like how when we took the SATs, we could solve math questions for the SATs. But can we really solve math? I don't know. So here's my test. And I'm going to show you what I do. Bear with me while I get my screen here. What I normally do is and I'm going to do it live. Give me 1 second here. So I take a single prompt. I'm going to do it right now. I'm going to take a single prompt. And I'm actually going to run it through what I call the Tron asteroid test. And so what I did was, I'm going to take a single prompt here. Let me just zoom in here. And I'm going to do it live here. The prompt that I use is make a HTML5 Tron-themed asteroid game. So this is GPT. And a few things that I like to take note, like, okay, when you're vibe coding, like what can it do? First of all, is how fast it is. The second thing is like, okay, when it's going through, and then what is the result of it? I'm going to let you know that ChatGPT takes quite some time to do this. So I've gone ahead and done with a couple of other large language models. The next model I did was Claude here. And I'm going to play this game and see what do you think about it. So the first thing about this game is, I don't know if you can notice, but I can't even move the asteroid left and right. I can't even move the space machine left and right. What it does do is actually it goes through and it shows me a score. I went through and did Gemini too, and I think Gemini is the best here. Like it's actually gone ahead and got a loading screen. It's got, hey, how do I start the game? And I don't know whether you can hear, there's actually sound too, but maybe not sound. Yeah, you can hear the sound, right? So this is Gemini. Again, this is a live test. And I can move around and zoom in and zoom out. So with my test of all the proprietary models, Gemini does it the best here. But what I found was, actually using the open source models, you can even get better results. So this is DeepSight by Hugging Face. And in DeepSight itself, you can go ahead and actually select an open source model. And what's really cool is you can choose the provider of the open source model. So in this case, DeepSight is using DeepSeek. I'm actually powering it using SambaNova. And I've gone ahead and created the asteroid game here. And what's really cool, I think this to me is the coolest here, because to me it looks like Tron and actually shows the lives down there and zooms in. I don't know, the effect to me is like, it's really, really, really cool. So that's, to me, I feel like if anyone's really starting to do vibe coding, I would strongly suggest trying out the different models. And possibly, if you haven't yet, I know some people said they're using Claude, go ahead and try DeepSeek, because it's bubbling to the top. And I suspect that they're not necessarily going for the benchmarks, but for real coding examples. So that said, I'm going to go ahead and look at ChatGPT, but this is GPT here. And as you can see, like I honestly have not gotten it working. I just want to demonstrate it to you. I've not gotten Asteroid working. So I'll just leave it, I'll leave it like that. I'm not going to throw shade in any company here, but that's GPT. All right, so let me go back to my, give me a second here. Yeah, so that's the benchmarks here. So I talked about different tools that I should use. I'm actually going to go ahead and show you 2 other tools that you can do. So those are tools within the large language model. But what happens if you want to deploy the code? As developers, we always want to build the code, but we want to deploy it. I think there's two tools out there that actually allow you to vibe code and do deployment straight away too. So I'm actually going to show you 2 different tools here. The first tool is actually Replit here. And Replit is actually running Claude as the large language model. And this is actually the same prompt that I used. I'm just going to go ahead and do it. It's pretty good. But the cool thing about it is that you can actually take this, you can fork it, and then you can deploy it to a live server. The next one is Lovable here. And actually, there's a publish button. I'm going to show you this here too. That's pretty good. I think so. I think it's really good. But the great thing about it is you can share it and fork it and then deploy it. So just to recap, you've got the large language models itself. You can go to each of their user interfaces and then actually in their chat and then vibe code there. And then if you want to deploy it, you can actually go to Lovable or Replit and do it there and then actually hit a publish button that will deploy it out publicly. The last one that I want to talk about is actually what most of us do, which is actually do it into an IDE. Give me 1 second here. Just going to pull out my slides.
You said Lovable, and what was the second one?
Replit. Yeah, REPL.IT. Yeah, I'm sorry, I'm giving you a ton of different tools. But I think if you're going to take away anything from my talk, is try different tools and experiment with it. Okay, so I talked about that. This is Replit down there. And I'm going to talk to you a few tips for vibe coding before I actually jump into the IDEs. So the first thing I would say is use version control. And then write tests. Or better yet, ask the AI model to write tests that are going to execute your code. The second thing I would say is, another good tip is, if you're writing a game, you can actually use screenshots, pass those screenshots into the large language model, and then have it code that application for you. Another thing I'll say is roll back when something breaks. I think when you're actually vibe coding, now I did a couple of vibe coding there where I did 0-shot prompting. I just went ahead and prompted it with 1 prompt. But you're going to run into errors when you vibe code. So don't hesitate to return to a known checkpoint or hit undo if you actually run into an error. Work with the large language model to come up with a plan. Treat it like a conversation. The more details you can when you're coding, the better. This is what I found when I did it. Small fixes and modularity is your friend. Keep your project tidy. So just like anything else when you're building a project, the better you can keep your files in sync and neater, the easier it is for you to know what's going on. It's easier for the large language model to know what's going on. The last thing is bug fixes. Now, I showed you a few examples where the program came out well. A lot of times you're going to run into bugs. And if in doubt, there's 3 different things you can do. One, you can try switching models. I'm going to show you different ways how you can switch models in IDE. The second thing is reset. Because it is so easy for you to do it, reset and start again when needed. And then the last thing I'll say is add logging. Just like when you're coding, logging is your friend here. So just knowing what's going on, knowing what is wrong, helps you out a lot too. So with that, I'm going to go on to my live demo here. Actually, before that, I'm going to talk about 2 different other tools here. I think, none of us actually codes within a chat interface. Most of us code within an IDE, or I use Visual Studio Code to do that. The first one that came out a long time ago is GitHub Copilot. And then 2 other tools actually became popular. One is Cursor. I'm sure many people have heard of that. The other one is Windsurf, which used to be known Codium. What I like to say about these tools is that, one, there's a monthly plan on it. And they also don't allow you to choose the models that you want to use. So I don't know what this tells you, but for example, GitHub Copilot is $10 a month, Windsurf's $15, Cursor's $20. Sometimes I like to think you get what you pay for. So I don't know whether the more expensive one's better. But one thing I do know about these tools is that they don't necessarily let you to choose what models you use. And to me, that's important. Like, why is it important for me to choose what models I want to use? We can see that each model outputs a different type of output. And also, I want to take ownership over my own data. So with that, the best tool that I personally use is Qlay. Why? One, there's not a monthly fee. You actually pay per your model usage. The other thing is this is fully open source, and you're allowed to use open source tools, large language models. And one thing you can do is actually you can use, I'm going to go ahead and find my screen here. So this is Qlay here, and it fits, sorry about that. All right, so this is Qlay. It's just a plugin into Visual Studio Code. And I'm actually and what you can do is you can actually select which model you're using. So here I'm using SambaNova as a provider. I provided the API key. I'm actually going to use a distilled version of DeepSeek here. And I think I had enough of Tron games. I'm actually going to say something really interesting, which is like, make me the coolest HTML page ever. Then I'm just going to go ahead and do it. Now, what's really cool about Qlay is that you've got different checkpoints there, and it'll execute the task for you, it'll plan it out, it'll go ahead and show you the code right within your IDE, execute it, and then run it for you. And you can see it's actually really fast. The reason why it's running on our SambaNova Cloud here, executing this task. And this is interesting. Just like that, I'll put it the coolest looking HTML ever. Well, I guess that's pretty, to me, I guess that's the definition of cool for the large language model. So the last thing I want to show you, just before we end here, was why we think running on a SambaNova Cloud really helps you code quickly. So this is the SambaNova Cloud here. What we do is we provide open source models that run on our cloud, and we run it on a chip called an RDU. And we pride ourselves to be having the fastest inference ever. So this is not cached. This is not a video. I simply typed in the code here, make a HTML5 Tron-themed asteroid game, and I'm going to go ahead and hit enter. And just like that, again, this is not cached. The AI is actually outputted in a matter of seconds. So it only took 3 seconds to output the entire code. And so that's why we pride ourselves on being the fastest AI inference. So if you're coding, as you can see, and you want to use an open source model that's quick and affordable, you can use SambaNova Cloud to power your model using Qlay. And these are a couple of models that we run. We just started hosting the Llama 4 models too. DeepSeek, OpenAI, and Qwen. I would encourage you to try out all of them. So anyway, that's all I have. You can go to cloud.sambanova.ai to try out Cloud. My name is Justin, and these are the ways to contact me. Any questions, by the way? Yes?
Thank you, Justin, for your presentation. Great presentation.
Thank you.
Yeah, I was wondering.
Do you need a microphone? There's a microphone here.
Thank you for your presentation.
Yes.
Justin, tell me about SambaNova Cloud. You know, when we have, a lot of different clouds.
Yes.
We got this cloud, that cloud, but we are looking for a cloud which I heard for the first time because I heard about, Yahoo Cloud, Google Cloud, Amazon Cloud.
Yep.
And Alibaba Cloud.
Yep.
It could be Indian Cloud.
Yep.
It could be some Chinese
Yes.
cloud. It could be Elon Musk Cloud.
Yes.
Tell us about the clouds concept of, from a consumer point of view. Somebody who's a user, says, well, I got this cloud, I got this cloud. Idea is to have a user-friendly interface.
Yeah. So,
Make it make sense?
yes, I'm going to repeat that question for you. I think you're asking us in general, why SambaNova Cloud? What makes our cloud maybe different? Because there's so many choices out there. Right now, like you said, there's Amazon Cloud, Google Cloud, everyone Cloud. Why do we feel SambaNova Cloud provides something different that other clouds don't? And I think that's just a credible question. Two things. One, we talked about speed. I think artificial intelligence says we're the fastest inference. You saw the speed that I did in the SambaNova Cloud. I put in the input, the prompt, and immediately I get a response. So like ChatGPT, normally you have to wait a couple of seconds. Claude, Qwen, you wait a couple of seconds or sometimes even minutes. For us, that was instantaneous. Like just to write 3 seconds code.
Would you say it's like a latency is better for you?
Yes, the inference speed is actually the fastest.
The latency is good.
Yeah, correct. For what we call the tokens per second, or the way when we output each token, we pride ourselves on being the fastest for almost every model. Yeah. The other thing I want to say is, we host a ton of different models too. So sometimes when you go to one cloud provider, they may not host all the different models. For us, these are all the models, and we're adding models every day. So as a new model comes on, we immediately add on to the model provider. And we also pride ourselves on being the most efficient. So, and you want energy savings, all these models, most of them run on a single rack, and this rack is very efficient. Yeah, hopefully that's a great question, by the way. Yeah, thank you. Any other questions about vibe coding, vibes, or? No? Yeah, so, yeah, go ahead. Yes. So the chip, I think I'm going to repeat the question. We run it on I mentioned that we run it on a specific chip. And maybe more details on the chip. So the chip that we run our SambaNova Cloud on is called an RDU. It's a reconfigurable data unit. And that reconfigurable data unit is actually built for faster inference. So as you know, like a GPU way back when wasn't built, maybe it's built for AI, but it was built for like graphics or ray tracing, basically rendering graphics. Our chip, we saw that inference, or the speed of inference, is something that people need. And we built a chip that allows you to execute, and the instruction set is best case for inference itself. So we believe that faster inference or faster token output is the thing that developers, that everybody, that the community needs, and we built a chip specifically for that case.
How fast?
Yeah, so I showed you down there. One thing, of course, we pride ourselves in being faster than everyone else. But I think, let me go back to, so this is our cloud product itself, and I'm not cheating anything. Maybe why don't I type in something like I don't know, what's a prompt that something that's long maybe. Someone say something. Maybe okay. How about build me a snake game in HTML5 or something. Sorry, I'm typing. Game in HTML5. Make it really complicated. And it's so fast that like once I've hit start, immediately all the code is out there. Like I can't even scroll fast enough to go through and see the code. I mean, like again, all this took was like 4 seconds and 629 tokens per second. The first token was like in a matter of milliseconds. You know, if I took the same prompt and then I put it into like, let's see, I'm gonna find my screens here. Let's say I did this here, make a HTML5 Tron theme in ChatGPT. This is ChatGPT here. And you can see a comparison. The inference to me is just like, it's just so much slower, right? So even the thinking and the reasoning comes out and like it needs to think, plan, and then execute. And either way you can see that it's just a lot slower than our inference speed itself. Hopefully that gives you an idea. Yes, that's our chip. Our chip is the RDU that allows for the fastest inference. Yeah, which gives you the best output of tokens per second, and that allows you to do tasks like in vibe coding, allows you to iterate, produce code, execute, go back to the code, undo a lot faster than other large language models itself. And we support all the open source models. Yeah.
Where are you incorporated?
Where are we incorporated? Well, we're based in Palo Alto. So yeah, that's where we're at. You know.
C Corp, LLC.
You know, I'm just a developer. I'm a developer there. I'm not. I can we can find that. Yeah, that's more out of my domain of expertise. Yeah. Anyway, I'll be around for other questions. Yeah, please, and if you can, go ahead and if I were you, go to SambaNova Cloud or SambaNova AI. Use the model down there. We give you $5 of free credit, and you'll see how fast it is. Yeah, thank you, everyone. Sorry, I went a bit.
Okay, cool. That's it. Those were the 2 exciting panels, and I just wanted to say thank you to everyone that's came today. And yeah, all right. Feel free to grab more sandwiches and whatever beverage we have. Yeah. So okay, thank you. That's it. Have a great day. Bye bye.